We are still going to be looking at and talking about properties of exponents today. So we're still in this same world, but we do not have any new properties to add. So we've gone over all of them. We just want to talk about what it looks like when maybe we have some problems to simplify that are a little bit more complex, or maybe when we have more than one property happening at the same time. So just as a short reminder, it's kind of nice to have that list to reference back when, right, none of them are matching our normal properties. So as our reminders here, if we are adding or subtracting, then our exponent stays the same. If we are multiplying, then we are going to add the exponents. If we have two exponents happening, an exponent to an exponent or a power to a power, then we will multiply the exponents. If we are dividing, we subtract the exponents. Let's see, if anything is to the 0 power, right, then that equals 1. And a negative exponent tells us to move it to the other side of the fraction. Okay, so those are all the properties we've talked about over the last few days. So now what happens if we start sort of putting those things together? So let's say we have a problem like 3y squared times 2y to the 5th all over 10y to the 9th. Now, one of the things that my students tend to find the most frustrating is they say, Mrs. McKinney, just tell me what to do and I'll do it. And there isn't necessarily a perfect order that you have to do things in. So I'm going to give you some suggestions, some guidelines, some things I recommend, but it doesn't mean it is the only way. As long as you are sticking to our math rules that we already know about coefficients, the big numbers in front, and our new properties that we've added about exponents, you could choose to go in different orders and still get the correct answer. Okay, so looking at this problem, my recommendation is that if we see a fraction, we look and see if there's anything we can simplify in the numerator or the denominator and sort of look at those individually. So if we look at the numerator, is there anything that we can simplify? Well, yeah, we see multiplication. Okay, so our rule with multiplying says that we're going to add the exponents. Now, the big numbers, the coefficients, function as they always have. So 3 times 2 is 6. And y squared times y to the 5th is y to the 7th. Okay, so we know 3y squared times 2y to the 5th is 6y to the 7th. Then we're going to look at the denominator. Nothing that I can do or simplify there, so I'm just going to leave that as it is. Now, we don't want to stop here. We want to continue because we still have more work to do because we also have a fraction which tells us to divide. And when we divide, we subtract the exponents. Now, once again, right, our coefficients function like normal. So 6 divided by 10, well, it doesn't divide evenly, but it can be reduced. So 6 and 10, you can either do in your calculator or they're both divisible by 2. So that becomes 3 over 5. Then we'll subtract the exponents. 7 minus 9 is negative 2. That negative tells us that it moves to the denominator. Or you could also think about this as the larger one is 9, right? 9 minus 7 is 2. 9 is on the denominator, so it goes on the denominator. At this point, there's nothing else that we can simplify. So our final answer for simplified form would be 3 over 5y squared. Okay, so what if we had 4x squared plus 7x squared over 3x to the 3rd times 4x. Right, if we look at this, we're going to see several properties happening. We see addition, we see multiplication, we see division. Okay, so again, my recommendation is that we're looking at the numerator and the denominator and we're simplifying them first. Up here, because this was multiplication and division, we wouldn't have been wrong had we done something like the 2 over 10 and reduced that. Here, that will get us into some trouble because this has an addition sign, and addition holds those together tighter. Those aren't, multiplication and addition don't fall in the same world, right? They're not inverses. So simplifying that numerator and denominator first is going to be sort of important here. So when we're adding, the exponent stays the same. So a 4x squared plus a 7x squared gives us an 11x squared, right? The exponent stays the same. And then we'll look at the denominator. A 3x to the third times a 4x, right? There's really an exponent of 1 here. So 3 times 4 is 12. And we're adding the exponents. 3 plus 1 is 4. But again, we're not done yet. We still have division. Division tells us to subtract. Now, we can't reduce that 11 over 12, so that's just going to stay. But we can subtract these exponents. So 2 minus 4 is negative 2. So we're putting that on the denominator. Or, right, we could think the larger one is 4, 4 minus 2, so it goes where the larger one was. What if we were given 18 x to the third, y to the negative 2, z to the 0, all over 10 x to the 7th, y to the 4th. So if we stick to sort of the original statement of simplifying the numerator and the denominator, well, we don't have an operation happening in the numerator or denominator. So some of us might see some different things first, and again, that's okay. Now, in my brain, if I ever see something that's to an exponent of 0, I tend to sort of take care of that as soon as I can. And so I just turn that into the 1. I don't need to say 18 times 1, so it just goes away. Okay, I also might say, okay, well, I see 18 over 10. I know I can reduce that. So those are both divisible by 2. So that gives me a 9 over 5. My x's have matching bases. So I can subtract those, right? If we do 7 minus 3, which is 4, 7 is larger, so it's on the bottom. Or 3 minus 7 is negative 4, which still tells us it goes on the bottom. So we've done those, we've done those. Now we have to deal with this y to the negative 2 over y to the 4. Again, there's multiple ways that we could deal with this. Option 1, we could see the division and we could decide that we're going to subtract. So negative 2 minus 4, be really careful with that. Negative 2 minus 4 is negative 6. Negative tells us on the bottom. If you do 4 minus negative 2 with the 4 being larger, it's still going to give you y to the 6th on the bottom. The other thing that you might see looking at this is you might go, well, couldn't I see this negative exponent and have moved that to the denominator? Well, absolutely. So then we'd have a y squared on the bottom. And when we're multiplying, we add. 4 plus 2 is 6. And so we still have that y to the 6th. So our final answer on this one would be 9 over 5x to the 4th, y to the 6th. We're going to look at one last example here. What if we have 8a to the 4th, b squared, all over 2a to the 5th, b, all squared. Again, we see multiple operations. Okay, we have that extra exponent sitting out here. We have division. My suggestion, though again not required, is that we focus inside parentheses first. Now, we could take this exponent of 2 and start passing it out. But I think if we simplify anything inside the parentheses first, it's going to give us smaller numbers to deal with. Okay, so that's my suggestion, is that we focus sort of in here first and we do the division. So 8 divided by 2 gives us a 4. When we subtract the exponents, we end up with an a to the first, but I don't need to write it, right, in the denominator. 2 minus 1 is 1, so we have a b to the first in the numerator. Now, we still have this exponent of 2. Now we can deal with this exponent of 2, and we give that to each individual item. So 4 squared gives us 16. I mean, we multiply exponents here, but 1 times 2 is 2. Not too much to multiply there. Same thing here, right? 1 times 2 is 2. So our final answer is 16b squared all over a squared.